Am I on? Okay. Yeah, sorry about that. Now that I'm here and I'm actually on the speaker, I'd like to open with a story. I was thinking about how to introduce this, and the story occurred to me was perfect. So I went to California in late January, and when I boarded the plane, the Donald had just issued the Muslim ban. I was flying for 11 hours, and when I landed in San Francisco and we walked towards the immigration building, the protests were full on. So we heard them chant outside, and after 11 hours of flight, European time, 2 o'clock in the morning, we faced a huge queue. Because of course, the custom officers, they were overwhelmed and understaffed, and most of them were outside because of the protests. And we had a queue of 3 hours in front of us. So while we're standing there with families, small children, a couple of techies, I was assessing the situation. And I got this impression there's a huge queue and nobody's really paying attention. And there is a single barrier which I could easily slip underneath. It was a simple thing to pass the US immigration. It would be so easy. I felt I was passing out a bit, and self-doubts came up, and in the end I decided I wouldn't do that. It would probably not be such a smart idea, but I felt like I could really exploit this. In the end, I made it to the front of the queue. I was questioned, all my backpack was undone. They had a lot of interesting questions. Finally, they sent me on into the United States, and when I thought I had passed the border, I came into a huge empty hall. And people were only trickling in, of course, because the long queue. So there was empty and a single person at the very end. And all the person did was checking a handwritten mark on my immigration form. So obviously, I was facing multiple layers of security. And the first layer was highly sophisticated, a trained custom officer who was interrogating me. And the second layer was extremely stupid and simple. And it would have easily defeated me immediately. I would have been able to pass the first one, but passing that second, very stupid layer of defense would have been, for me, impossible without the knowledge to put this mark on the form. So what brings us this? What I want to propose you and what I'm going to talk about is that we need multiple layers of security. What we need is additional layers of security which are a good return on investment, so simple to set up, easy to operate, adding an additional benefit, additional security for your system, your service, or your organization. And as it happens, the OWASP ModSecurity core rule set is such a system. I like to liken it to seatbelts. We all use seatbelts when we drive cars. We all know a seatbelt is no silver bullet. Not all car accidents will be harmless because of a seatbelt, but we know for relatively little hassle, we add a lot of safety. That's why we put it on. It's a natural added safety layer when driving a car, together with a front airbag and a very well-built modern car. And all together, they form a safety package. So it's additional 80%, multiple 80% solutions stacked on each other, which together bring us good security. What is the program today? I somehow ended up in the CISO track. That was not where I was expecting ModSecurity. So I introduced 1 or 2 slides to introduce the basic concept on this. I hope to take the whole room with me there. Then I had planned to do an installation demo on my notebook, not on this notebook, unfortunately. So we have to skip the installation demo. That happens. And then I'm going to present a few research results. I'm going to walk you through key concepts of the core rule set and how you can use them. And then near the end, I'm going to present you with additional documentation that should take you from here to higher level of security. What you can do when you return to your organization next week to try things out, where you find additional tutorials, information, documentation. So let's dive in. Web application firewalls. Web application firewalls are basically sitting on a server inspecting incoming and outgoing HTTP traffic. They try to catch malign requests and their suspicious responses. Of course, you can argue that putting a smart device in front of the code is a very stupid idea. Wouldn't it be better to fix the code in the application? But I think if 20 years of web security have taught us one thing, is that fixing the code completely is extremely hard. And it seems that recipe doesn't really work in the real world. So an additional layer of security can be or should be added in form of a WAF, which is one such layer. The PCI DSS standard recommends WAFs. It is a highly contested area. There is a hard commercial competition, lots of hype, lots of marketing, and lots of fad. In the end, I think WAF installations boil down to three types. There are naive, overwhelmed, and functional WAF installations. Naive WAF installations, and I'm talking to the CISOs in the room. A naive WAF installation is a green check mark on a report. We have a WAF, we're secure now. That is naive. It's very likely it's not even in line, it's not switched on, it's in monitoring mode, nobody's paying any attention. That is a naive setup. An overwhelmed setup is one which is actually switched on, and it has a ton of interesting knobs and levers to put, a lot of ticks to click, and a lot of documentation, which is very hard to understand unless you're an expert. And when you really switch it on, you're overwhelmed by log files and reports and likely false positives. And very often people put it in the corner, or they wait for the boss to call and tell them, switch this shit off. It blocks our customers. Then there are the functional WAF setups, which are, it's a rare species. My job is taking people from naive or overwhelmed over to functional, and it's kind of hard, or it takes specific knowledge, or it takes the right tool set or the right documentation. It's not the standard business to achieve this. What I'm going to show you now is that with the ModSecurity core rule set, in the modern version, you have a very basic setup which gives you 80% of the security by default. And once you're comfortable with that, you can raise to even higher levels. So for a very little resources, you get a very good security level without all the hassle and be functional from the start. So ModSecurity. Open source people kind of hate WAFs somehow. And that's why almost all the WAFs are commercial. There are dozens of them. In Switzerland alone, there are 3 commercial providers of WAFs. So what you end up, because all the open source people hate WAFs so much, you end up with a single free, all-purpose WAF offering, which is ModSecurity. There are a few specialized ones as well, but ModSecurity is doing the whole web. ModSecurity is actually an Nginx or Apache or IIS module. Most people use it in Nginx or Apache. It's a server module which provides you with an engine. So it's the basic engine, and on top, or with the help of that engine, you're then building your WAF functionality. So you need rules on top. In fact, there are quite a few of the commercial WAFs who have a ModSecurity underneath. So the 3 Swiss WAF offerings, one of them has ModSecurity inside. And quite a few of the other commercial ones, they have ModSecurity and likely Apache under the hood. They're just not advertising that fact. So what is ModSecurity? It is not a modern, sophisticated, artificial intelligence, super smart, cloud-enabled mastermind, not at all. ModSecurity is much more resembling a mechanical Swiss watch. It is a mechanical device based on rules which gives you granular control over requests and responses down to the byte level. And to make use of this functionality, you need rules, and you either hate yourself and you write them yourself, which is really hard, or you take a good predefined rule set. And the OWASP ModSecurity core rule set is the standard rule set most people use with ModSecurity. But it's not the only one. And it's two different projects. So you have the engine and the rule set. You need to keep them apart a bit in mind. So once you have the engine, this is where the core rule set comes in. Here we are. So the OWASP core rule set is a venerable OWASP flagship project of over 10 years. So it's been around for quite a long time. It has died down a bit during the years, but there is new management now. So Kame Sanders took over the lead of the CRS project in 2015 from Ryan Burnett, who quit the ModSecurity community. And Kame recruited Walter Hopp from a Dutch hosting provider and me to form the core team of this project. We're now growing the project again, building the community. And last winter, we released CRS 3, so core rule set 3.0, which is the first major release in years. And the focus of that release is working on false positive. I'll come back to that in a second. So the project has been revived. We're alive and kicking, and we're open to more people join us to share the workload. And we have lots of very good ideas, apparently, as every cool project. We just don't have enough hands to type all the cool rules. We also did a very cool release poster, I think, with the help of OWASP, who paid for this. And if you like the poster, I have a few of them with me. Come and see me after the talk. There must be like 10 or 15 of them left. I handed a few out already. Okay. Now we would do the installation demo. What would be the installation demo? It would be this, basically. As you've seen, my notebook doesn't like the Beamer or the other way around, so I'll walk you through it orally. The core rule set is hosted on GitHub, apparently. You clone it, and then you get all the rules. The rules is a set of about 24 of files, which are part of this distribution. There is a setup file, which you copy. So there is an example, and you copy it over, and then you can leave it as is. The defaults are very sane, and defaults are fairly secure. The default installation is the basic security package you want to have on any web server. And then you go to the server configuration. Depends a bit which one you use. This one is Apache syntax. You include the CRS setup conf, so this configuration file, which is created, you include this, and then you include asterisk conf, you include the rule files. That's it. That's the whole installation. In my demo, this took me 2 minutes. And what do you get with this? You get a set of rules, like 150 rules, which were executed sequentially when a request comes in. And these are mostly regular expressions looking for specific patterns. Now, you could do, there is Snort, an IDS, which has very clear exploit-oriented patterns. The core rule set is much more generic. It doesn't look at an attack, an individual exploit. It looks at a basic pattern. For example, we're using the libinjection library, which is very strong at detecting SQL injections via tokenization. So it tries to take a parameter, includes it in standard SQL queries, and try to make sense of it. Will this result in a parsable SQL query? If that is true, then it's probably an SQL injection attack. This is a very successful, fairly new approach, which we make use of in the core rule set. And then lots of additional stuff. Once the demo included a request to a very stupid little application or script which would display local files. And of course, you can also use it to display the standard system files on a system. And that works and is highly vulnerable. You should fix the code. If you don't fix the code, then put at least the core rule set in front, and it would identify the parameters because it knows people usually tend to display the password file on a Linux system. So it knows several hundreds of standard files which will no longer allow as a parameter in a request. That gives you a good basic security. So the core rule set are generic rules which don't block everything, but most of the stuff. Does this really work in practice? Yeah, it does. This is a graph from research I'm performing with Damiano Esposito from the Zurich University of Applied Science. So I'm the defender and he's the attacker. He's the expert on application vulnerability scanners, especially he's very strong on burp. So he created or let burp execute 4.5 million requests against a vulnerable application. It was an application, don't tweet just yet, the slide will be even better in a few seconds. So the vulnerable application we had was WASP. WASP is a web application firewall evaluation project. So it's broken to see will the WAF protect everything, or the security scanner, will he detect all the weaknesses? That's the plan. And when burp attacked the WASP, it had, out of the 4.5 million, it would tell us that almost 1,100 of his requests hit a weakness immediately. So that's the basic no protection setup. And then with this simple configuration, so we put this in, and then we removed the burp identification because it would be very easy to identify burp on the user agent. So we had burp hide the user agent to be not immediately identified as burp. And with this basic installation, we came down to 170 vulnerabilities in the default install. On the right is a short interpretation. In the default install, we're not doing very good on redirects and remote file inclusions, but the local file inclusions, they're essentially gone. That would be the moment to tweet. In fact, I would welcome that. It's a very cool slide. Cross-site scripting is mostly gone, and your SQL injections for burp have disappeared. So burp is no longer able to push an SQL injection on a vulnerable application. I'm not stating that it is impossible to do an SQL injection with core rule set in place. That is not the case. With the help of a very stupid application, you might still be able to push an SQL injection through, but it's getting a lot harder. And the average security scanner will no longer be able to do this. And even burp, I mean, Damiano tweaked burp extremely well to take the maximum out of it. So this is no standard burp setup anymore. That's a very strong burp setup in here. And the research is not finished yet. We're continuing with SAP, Arachne, Wapiti, and additional security scanners. And we hope to finish this work during the summer. We're not looking at the additional bars now, just the first two ones. I'll return to the slide later on. This is the rule files which we included a couple of minutes ago. These are the rules targeting the request. They're part of these files. Depending on the file, there are more or less of them. All combined on the request side, they're like 150 rules. So we do scanner detection. Obviously, that's where we usually detect crawlers, scanners, bots. We do protocol enforcement. There are quite a lot of rules in this. And this counters the hippie attitude, or let's say liberal attitude of web servers when it comes to protocols. They tend to swallow everything. And core rule set is much stricter. If you're not issuing a user agent, then you're probably not a browser. If you have a numerical IP host header, then you're unlikely to be a browser, and so on. So the protocol is quite strict how an HTTP request should look like. The server is very nice with you, but CRS is not. Either you comply or you hit the limit. Then an additional group of files is targeting individual attacks. So we're very strong on remote command execution, especially in CRS3, very strong on PHP injection, good on cross-site scripting, and I think very strong on SQL injection. Traditionally, SQL injection has been the strongest area of core rule set, and this has improved even more with the CRS3. The request is running through all these rules, throughout these files, and then at the bottom line, the 949 is the blocking evaluation. So it is only then that the core rule set will decide, will I let this request in or not? It is not blocking immediately by default. You can change the behavior, but the standard behavior now is to look at all the rules and then draw the total in the end. Outgoing, the response rules, they're a bit fewer in numbers, and as we came to see in the research we did, we're a bit weaker here. So these patterns are a bit outdated. So it seems a modern Tomcat is issuing different error messages, and CRS was no longer able to identify all of them. So we let error messages, Java stack traces out to the client, which is of course pretty bad. So after the research, the first step of the research, we created 13 issues on weaknesses which we identified in the rule set. Mind you, one of them was really annoying. We had a cross-site scripting passing the rule set in a fairly high security setting. So I think that was the biggest issue with this research that we showed up. Most that passed through were redirects or out-of-band communication, which is really hard to detect when the client submits a host name as a parameter, and the stupid application does a DNS lookup on that. So that is out-of-band communication, and that's really hard to catch for us. We'll see if we can do anything about it. So we run through all the rules, and we do kind of a scoring. How does that work? I need a bit of support here with this. I need a few volunteers to demonstrate how this works. Could I have like 5 or 6 guys come up on the stage, please? Ideally, the first ranks. Come, guys. Okay, that's 5. That's already very good. We have somebody with a hoodie. Thank you. I forgot a piece. Okay, so very good. You stand here at the very end. You guys here, you're going to be our evaluation at the end. This is the limit. Could you two guys take this? And we need an additional volunteer. Could you come on? One of you. So at least 3 rules. That's very good. Stand here, please. So these 3 nice gentlemen are our rules. And they have score tags. That's a +5. You're a +5 rule. You're another +5 rule. And he is only 3 points. And here on the left, we have our attacker. Could you put up your hoodie? Because attackers are always wearing hoodies.
Binary behind me or anything?
Yeah. And look very dangerous, please. And we're easing into an installation. So the limits we are setting is really relaxed. Put this bar very, very high. And now our attacking request approaches the web server. And here is the SSL, the TLS layer, and here starts HTTP with the core rule set. Please approach the rule set, and now all the rules will examine him. And you can decide, do you identify him as an attacker? If you do, then you put your 5 points on his back.
He's wearing a hoodie.
He's wearing a hoodie. Yeah, that was easy. Then you approach the next rules, and basically we have like 150 of those stacked behind each other. But we're not enough people in the room, and we don't have enough time. So you identify him as well. Yep. Yeah. But no longer on the hoodie. You examine something else. So there are different characteristics of a request covered by different rules. You see anything, or you let him pass? He's fine. And in our setup, because the limit is very relaxed, he will easily pass. So despite triggering 2 rules, he's passing. That is a test procedure or a test setup where we don't want to annoy the standard users. The application should continue, and we want to examine the behavior. So pass underneath. Attacker passed, exploited, we're probably already doomed. Okay, I'm handing you back again. And then we examine the logs, and we might have to treat false positives. And then when we start to trust the system a bit, we lower the limits in multiple iterations. I usually tell people to take like 5 iterations to get into a hard blocking production mode. So the default installation, which I showed you, is already blocking, but on a production real commercial system, I would raise these limits to start with a bit, just for a practical setup. And then you can go as low as you wish. I would say knees level that is 5. Are you good in dancing the hula? Yeah? Will you manage?
I could.
You could? Okay, let's give it a shot. He needs points. Okay, no, you need to go to shoe level now. But then you would give up, wouldn't you? Okay, so did you get the idea? This is how this scoring works. We have multiple rules working together, scoring an individual request. We're always looking at the request. We're not session-oriented. We're looking at an individual request with the current rule set. And the lower you go with the limit, the harder you are. So that is a basic concept. Thank you, guys. So anomaly scoring is a basic concept of the core rule set. Other basic concepts is below here. So on the left, you had the node protection. Then came the default install, and then came a paranoia level 2, 3, and 4. And the higher the paranoia level, the less attack requests would be able to pass the rule set. So the higher the paranoia level, the harder for the attacker. How does this work? We have 4 paranoia levels. The default is paranoia level 1. This is what we call the basic security level, with a minimal set of false positives. So we have organized the rules on the likeliness of false positives. In the default install, you hardly get any false positives at all. If you get false positives in the default install, please open an issue on GitHub. We want to know, we want to improve this, we want to tune it. You should not face any false positive in a default installation. Traditionally, core rule set had a ton of false positives. That made it very hard. But this is no longer the case. The CRS3 really aimed for false positives. In the default installation, they're gone. They're hidden now in higher paranoia levels. If you raise the paranoia setting to 2 in the setup, in the config file which we created at the beginning, you're now a security-aware application. You say, we have real assets which we want to protect, and we are accepting false positives from time to time, which we have to handle, which we have to prepare for. I'm returning on the topic afterwards. And then at paranoia level 3, you get more rules, more specialized rules, and also more false positives. If you look back here, you will see that's paranoia level 2 and 3 are almost the same. So this is fairly new, and we're adding more rules in here. So right now, PL3 does not give you much benefit, but this is where the development happens now. And this I would call online banking level security. Paranoia level 4, which is really insane, is then the top level of security. I call it the nuclear power plant level security. Or I'm working on an e-voting system in Switzerland, so online voting, where we want the highest security possible. And one of the many, many security layers is a paranoia level 4 ModSecurity core rule set setup, which makes it quite tricky for an attacker to pass this. So these paranoia levels, how do they work in practice? Basically, if we look at an example, the protocol enforcement, at the paranoia level 1, we have 31 rules. And then at level 2, there is an additional 7 rules, which are a bit harder, a bit more aggressive, a bit more paranoid. And as you know, with paranoia comes either aggressiveness and fast judgments, misjudgments, craziness, and false positives. A false positive is a dog biting the mailman. It's a guarding dog who attacks a good person. That is a false positive. And you don't want false positives. They start to pop up at level 2. At paranoia level 3, we only have 1 additional rules in the protocol enforcement. And at paranoia level 4, we have 4 additional very tough rules. Let's take an example. Let's take something which we call stricter siblings. Stricter siblings is like a family of rules. There is a rule or a group of rules which targets byte range enforcement. So we're targeting the ASCII range, and by default in paranoia level 1, we say we're accepting the full ASCII range minus the null byte. There is no reason ever to submit a null byte to a web server. So this is illegal, but we're okay with all the rest. This is basic security. In paranoia level 2, there is a new stricter sibling which says we only want the full visible range now. All the crazy steering codes, they're no longer acceptable, but we also take in tabs and the new line in. That's okay. That happens in text areas and stuff like that. In PL3, we concentrate now on the lower ASCII range, which is visible, and no longer the percent sign. Because the percent sign, you can encode a lot of crazy stuff in that. We no longer want to see that. And then in paranoia level 4, we're super strict with enforcing the byte range. There is only a couple of characters which are allowed now. And it will be very hard for an attacker to create an attack using only these requests or ASCII characters in a request. I think you get the idea, don't you? That is fairly straightforward. So these are stricter siblings. What else? The sampling mode. Sampling mode is a basic concept. When you start a new service and you start with ModSecurity from the beginning, initial testing, that's great. But often people, they already have a production service. They have a lot of traffic. And ModSecurity adds a load, it adds latency, we cannot deny this. And we wanted to give people the means to ease into an installation. That is the sampling mode. So you define, in the config file again, you define a percentage of requests which should be funneled into the core rule set. So if you set this to like 10, then 90% of the requests will pass through the core rule set or around the core rule set, and only 10% will be funneled into the rules. And this allows you to gauge the viability of this core rule set on your existing server without affecting all your customers immediately. And this is very good to trying out the performance. Is the web server able to swallow this? That's really helpful. Sampling mode. So let's come back to these false positives. I wouldn't say it's a basic concept, but it's a basic occurrence when running above. The commercial vendors will tell you they don't have false positives, and I think most of them are lying. Because you cannot tell good from bad without having a false positive occasionally. CoRuleSet has false positives. Very few ones in default installation, but as you raise the paranoia level, you go to higher levels of security, they'll pop up. What you do with them? What you need to do is you need to write rule exclusions. And a rule exclusion is basically a ModSecurity rule again. It is a rule which disables a different rule. There are basically four rule exclusion types, or basic patterns, and I'm explaining this in a series of tutorials which I've written. You can download them at netnea.com, which is my small Swiss company, and there is also a cheat sheet to download from there. So these are the four patterns. How you can do that? You can disable a rule completely. That's fairly obvious. It's probably not the smartest way to deal with a false positive, but it's very straightforward. What you can do is disable a rule for a given path and say, look, this is the API. We're only client certificate authenticated requests on this path. I can disable this rule for this path. Fair enough. You can disable a rule for a given parameter. And you say, look, we're in a high paranoia setting. We're not accepting the full ASCII byte range, but on this particular parameters, we need to have special characters. So that is a standard way of handling a false positive. And you can handle them with a combination of the two. So disable a rule on a given path for an individual parameter. So these are the four basic forms of working with rule exclusions. And what we do, in fact, is we have set up this wall of CoRuleSet. At the highest paranoia level, the wall is very high. And when we face false positives, we have to pierce hole into the wall. And each of these holes is a little weakness. Let's be honest, it's a little weakness. But the biggest weakness is the boss calling switch the shit off. It's blocking our service. So when I'm teaching courses, I tell people, you better are fairly liberal with piercing a few holes. There are 180 rules all combined and a lot of parameters, a lot of paths. Disable individual rules to make sure the customer, the business is not affected. Because once you affect the business, the whole WAF is disabled extremely quick and you will not dare to switch it on ever again. So that's why we have the cheat sheet that really helps with handling false positives. And then we also have predefined rule sets or predefined rule exclusions. With the current release, we have packages of rules exclusions for standard Drupal and WordPress installations. Obvious, WordPress is the biggest application on the internet right now, very widespread, and running on PHP and notoriously insecure. And if you raise the paranoia level to 2, you get quite a few false positives on WordPress. And we don't want all the users to handle the same false positives. So we released the CoRuleSet together with a pack of rule exclusions. And if you run WordPress, you enable the WordPress rule exclusion in the config file again, uncomment a single directive, and then you have you covered for the basic WordPress installation. This does not mean it covers the plugins so far. Not for WordPress, not for Drupal. And this is also something we're hoping for the community, or we're building on a community to support us and submit the handling of their false positives. And we're very open to guide you through writing false positive rule exclusions or helping you interpret the log files to come up with good rule exclusions. And we want to include them in further future releases. In the queue, we have Typo 3 and PVIC default rule exclusion packs, and we're really open for contributions. That would be awesome to receive more of those. So let me round up before I come to the end and the questions. question and answer session. So the core rule set is a first line or a possible first line of defense against web attacks. In the default setup, you cover like 80% of the web attacks and the standard security scanner stuff. It is a generic set of blacklisting rules, 150, 180, depending on the setting, for the ModSecurity WAF. And it gives you granular control on individual requests, individual parameters to allow them in even on high paranoia settings. So that's the final slide. I'm Christian Folini. You reach me via email or via Twitter. I'm welcoming new followers. As it happens, I'm also the author of the second edition of the ModSecurity Handbook. I took this over from Ivan Ristic when he left the community. I have a series of ModSecurity CRS tutorials at netnea.com. I'm also running courses on ModSecurity, either in-house or public courses. And the book is about to appear in print. It has been on sale for a couple of months now as PDF. And there is a voucher code during the conference. If you want to download the book immediately, there is a 40% voucher credit with the code AppSecEU. And yeah, I think that's it. Thanks for having me.
Yes, thanks very much, Christian. There, fantastic. Any questions, please? Yes.
Yes, hello. My question is, you said that you have this bunch of rules and this core system. That's,
yes.
Yeah. And the question is, why we not like block the actual request if we reach the threshold? So why we need to go through all those like rule set?
Okay. What you can do is block the request once it hits the first rule. You can do this. And having it block once it hits the threshold has to do with the rule language. You cannot easily do this with the rule language because in a given rule, you can only examine a single characteristic. So what we would have to do is after each rule, look at the score again. And that's not practical and not very performing. So either you block immediately or you block after a given request phase. ModSecurity knows 5 request phases. So request header, request body, response header, response body, and logging. What we're doing now is we're blocking after the request body. But we have a feature request, which we wrote ourselves, to evaluate the score the first time after the request headers, because that would be a good moment to do it. This is coming closer to your idea, but to really do this, ModSecurity is not allowing this, unfortunately.
Yes.
Cool, lots of questions, I like that.
Hi. I'm wondering, you mentioned that ModSecurity is basically based on regex plus this additional library, and maybe you can go a little bit more into detail. Basically, regex are not capable of basically catching the full extent of context-free languages, what we are dealing with here. And so there are basically false positive and false negatives already in, which is basically the result from basic computer science.
Yeah.
Maybe you can comment on that a little bit.
Okay, I can comment on that. So ModSecurity is offering you like 30 or 40 operators. And the regular expression operator is one of those. It's the standard operator. Most rules are based on that operator, but not all of them. And what our rules are doing is they look at very small pieces of the request, each of the rules. And then they're overlapping a lot. Stricter siblings are doing the same, but stricter. So, and all combined, we think we kind of catch them. But it's definitely not a whole concept or a holistic view of understanding an HTTP request. It's looking at individual characteristics in the request. And this takes you only so and so far. Absolutely. And you can prove that you can work around every web application firewall given enough time. That's why I'm not saying this is your silver bullet. It's not. It is something which gives you a good level of security for not too much investment in resources. And you have to see the limits of this approach, absolutely.
Have you any comparative figures between the speed overhead? So you mentioned that these rules are being performed sequentially.
Yeah.
Have you any comparative figures for maybe, for example, paranoia level 1 versus 2?
Absolutely, yeah. There is a chapter in the book where we look at performance of ModSecurity. ModSecurity is extremely helpful when it comes to performance. Helpful in the sense it eats performance, but it also is very transparent where it eats performance. So you can very easily gauge the performance of individual rules, of individual requests. And I did this for ModSecurity and the core rule set at all the paranoia levels for the book. So I would say basically ModSecurity will add, you will lose 1 or 2% performance just for the fact of having ModSecurity there. And then an individual rule by its mere existence on a mid-sized Amazon server took me 1 nanosecond or half to 1 nanosecond. So all the rules combined were in a few hundred nanoseconds range. For a standard service, my experience is you lose like 5% of performance. You add 5% latency on top. I think this is defendable. You can do that, but it's there. And if you're in a bad situation, it can be substantially more. And then there are ways to deal with that. What you typically have, a performance hog is rules working with regular expressions on the response body. And then you have static files, megabyte big, and the regular expression takes 2 seconds. So that's crazy. And of course, what you do is you disable that, because if it's a CSS file, which is static, we're no longer inspecting it for SQL leakages. So yeah, you can handle that.
So can you give us some more color on the percentage of the improvement comparing to 226 or 228?
Yes. Let me go back to the rules. The biggest improvement is the false positives and the introduction of the paranoia levels. So you control the amount of false positives now, which is a big step ahead, really. And then the SQL injection is now based on the libinjection library, which was introduced with ModSecurity 2.8. That was 4 years ago, and we thought it's about time to use this in the core rule set. We can assume people should have upgraded by now. And the lib injection, it is great. So we kicked like 20 SQL injection rules and replaced it with this simple rule. We still have additional SQL injection rules, but that's a big improvement. Then Walter Hopp, the Dutch guy, he wrote a new set of remote command execution rules, which take a couple of hundred of standard Unix and Windows command line tools into consideration. It identifies them in all set of contexts. That's extremely strong. And he did the same with PHP code injection. So what he did is he made a matrix of their shell commands, which are very innocent and they resemble English language. That's no problem. But then, of course, there are shell commands which resemble English language and they're extremely dangerous. So exec, evo, system, stuff like that. And these are different groups, and we use different rules for them now and try to cover them all. And so that's, I would say, remote command execution, PHP code injection, SQL injection. That's the biggest improvement, together with the introduction of the sampling mode and the paranoia levels, which gives you a much better leverage, everything. The tutorials are there now. The documentation has been much improved. I would say it's much easier to run it. It's much easier for newbies. It's no longer expert stuff.
Okay, thank you very much. Thanks, everyone. That's it. Sorry, no more questions.